Have you ever stopped to wonder how our gadgets get more and more powerful every single year, but somehow they just keep getting smaller? Well, today, we're pulling back the curtain on one of the tiny giants that makes all of that possible.
I mean, really think about it. It's the central puzzle of modern tech, right? Our phones, our laptops, they do incredible things, way more than they did 5 years ago. But the guts inside just keep shrinking. So how do they do it? How do you possibly pack an ever-increasing number of connections into a space that's practically vanishing?
Well, a huge piece of that puzzle, a critical part of the answer, is a little component you've probably never even heard of, but you absolutely rely on it every day. It's called the Ball Grid Array, or BGA for short. It really is the unsung hero of miniaturization.
Now, unlike older chips that had those little metal legs or pins sticking out from the sides, a BGA is totally different. It uses its entire bottom surface. It's covered in this perfect grid of teeny tiny solder balls, and every single one of those balls is a connection point. It's a complete rethink of how a chip talks to a circuit board.
But here's the really cool part. Those solder balls do more than just connect things. They add resilience. You know how your phone gets warm when you're using it and then cools down? Well, all the materials inside expand and contract. Those little solder balls provide just enough flex to stop those microscopic connections from cracking under the stress. It's a super elegant solution to a massive engineering problem.
So you've got these tiny components with hundreds, sometimes thousands of invisible solder balls. How in the world do you attach them perfectly to a circuit board? Well, it's a process that demands just absolute pinpoint precision. Let's break it down.
The whole thing is kind of like a perfectly choreographed three-step dance. First, a machine lays down solder paste through a stencil, almost like screen printing a t-shirt. Next, another machine comes in and places the BGA component exactly where it needs to go, right onto that paste. And finally, the whole board takes a trip through a special oven, which melts the solder and the paste, forming a perfect permanent bond as it cools. And when it's done right, this reflow process creates an unbelievably reliable connection. Here's a neat trick. The surface tension of the liquid solder actually helps pull the chip into perfect alignment on the board. So it's not just a physical anchor, it's an electrical superhighway.
Okay, you might be thinking, wow, that sounds really complicated. And you're not wrong. So why on earth would anyone bother? Well, because the payoff is enormous. The BGA isn't just a different way to connect a chip. It is a fundamentally better way. It really all comes down to one killer feature: high-density interconnections. Fancy term, simple idea. It means fitting the absolute maximum number of connections into the absolute minimum amount of space. This is the BGA's superpower.
And this illustrates the difference perfectly. Think about it this way. Older chips like the quad flat pack were like a building with doors only on the 4 outside walls. You're pretty limited. The BGA, on the other hand, is like a building where the entire ground floor is made of doors. By using the whole bottom surface instead of just the edges, you get way more connections for the exact same size chip. It's a total game changer. And it's not just about density. Because the connections are so much shorter, signals can travel faster with way less interference. It's like having a crystal clear phone line instead of a staticky one. You get better performance. Plus, all that surface area contact means heat can escape much more efficiently. That's a huge deal. It's the difference between a phone that gets scorching hot when you're gaming and one that stays cool under pressure. It's a win-win-win. Okay, so we've covered the what, the how, and the why. But where does this tech actually pop up in real life? The short answer is, well, pretty much everywhere. Seriously? We're talking about the smartphone in your pocket, the powerful graphics card in your computer, but also the massive data servers that run the internet. They're in advanced medical equipment like MRI machines, and even in high-tech radar and sonar systems. All of these things rely on BGA technology to pack in the power and performance that we expect. So let's tie this all together. The Ball Grid Array isn't just another component, it's a foundational technology. It's the key that unlocked the door for engineers to build things that are smaller, faster, and more reliable than we ever thought possible. It really makes you wonder, doesn't it? We've gone from clunky pins on the side of a chip to an invisible grid of solder balls underneath. As we keep pushing the limits of what's physically possible, what's the next big leap in micro-connections going to look like? What happens when even the BGA isn't small enough? It's just a reminder that some of the biggest innovations are the ones you can't even see.